Ladies and gentlemen, I've just started recording, which means all those right answers are on YouTube right now, so there's no need to write them down. Look right now and go tick X, tick, 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 whatever you have. I'm going to leave this up here for about 5 more seconds, then I'm going to move to the next page because I want to check your homework. That is long enough. There is the next page. Don't worry about the little rabbit that I drew there. It's not important.
Okay. Ooh, I don't know if that's right now. Oh, what is that? Oh, okay, that's right.
I'm finished. All of page 52.
Hello? The top one. Can't see the top one. Oh, whoa. Okay.
That should be enough time for that. Now, if you were going to measure, I trust that everybody has some measurements, yes? Now, if I ask around the room, am I going to get the exact same measurements?
No.
Why not?
Because someone could start from the end.
Yeah, rulers are, so the answers are not going to be exact, are they? But they are going to be close enough for the theory. So who has a number for me for side A?
5 centimeters.
5 exactly?
Yes. I got 5.
First side. 4.5. Yeah, 4.5.
Okay, but look, I did. Okay, do this. Yeah. I took here.
I can see from here it's not 5.
Here.
No, go from the dot, not the letter. Go from the dot on the triangle. From the dot on the triangle to the next dot on the triangle. So, 4.5, yeah? Close enough. Who has a length for B? 7.3. And who has a length for C? 9. Now, who has a length for D? Who has a length for E? And F. Everybody cool? All right, now, you will notice that angle A compares with angle F. Why? Why have I done this comparison of angle A to angle F?
Because they both they're the first.
They both occupy the same relative position in both triangles, yes? Yeah. So, 30... Sorry, that's supposed to be 30.
You want us to write those down?
30 divided by 30 is 1, yes? 55 divided by 55 is 1. 95 divided by 95 is 1. When I compare all those angles, they are the exact same, aren't they? Did the size of the triangle affect the size of the angles? No. That is the key point. Angles are independent of side length.
So you divided 30 and 30.
Yeah, when I compared the two, it was 1, which means when you compare them, they're exactly the same. That's what I did there. That's a ratio. I compared angle A to angle F.
And how'd you get 1 though?
30, angle A, divided by 30, angle F. 30 divided by 30 is 1.
Was an angle F 35 though?
No, it was 30. I wrote it wrong because I was writing so many 5s.
Okay.
Is everybody cool? Now, if all your angles are the same, if your angles are the same, your triangle is similar. Your triangles are similar. I've already said that on the first page. It means something. So now let's check. What is the length of side A? We said it was 4.5, yes? And the length of side F was 7. So I'm dividing that by 7. What does that give me for an answer? 0.64. Okay? Everyone agree?
Divide those so it's
Now, let's compare B and E, because they're in the same position on the triangle. B is 7.3 divided by E, 11.5. What do you get?
7.5.
7.3 divided by 11.5. What do you get?
0.63.
63 what?
634.
63. Now, you're intelligent young people. All the angles are the same. And when I compared the two sides, we got almost the same decimal. What is going to be the answer when I do 9 divided by 14? It's going to be around what? 0.6, whatever you get. It's 6.4? Now, if we had exact measurements, what will we know about those three things? They're all the same.
Let's start with 16.
Okay? And this is why we can take blueprints and build this building. Because on a piece of paper, that triangle is way smaller, isn't it? But are the angles smaller? No, because size of the triangle is independent of the size of the angles. So if I get a blueprint that has a triangle drawn like this on it, and this side is 8, this side is 3.5 centimeters long, and this side is 4.5 centimeters long, and this side is whatever it is, say it's 6 centimeters long, and then I build that triangle, I know that I am taking this number and I am multiplying by what we call a scale factor. And that gets me the real life measurement. Now, all of you should have seen something like this in the 9th grade. Maybe you saw it this way. Maybe your teacher said this was 10.7 meters and this was X meters. And they wanted to know how long this side was. Then you would go 3.5 divided by 10.7, because you're comparing the 3.5 and the 10.7. That would give you a decimal, yes? And that decimal would have to equal 4.5 divided by X.
Why did you put 3.5? Okay, it's the bottom of the
Right? What if I reversed it? It would be the same thing. It would be 10.7 over 3.5 and X over 4.5. And then we would do this math. Has everybody... Toby first, then you. Toby. I used a protractor. I didn't give them to you because not everybody has one of these. And too many people don't know how to read it. And I'm not going to spend a day teaching you how to read this thing. A great many people do not. Is everybody has seen this before, yes? Now, to do trig, you have to understand how we label triangles. Capital letters, small letters. You have to understand what opposite means. And you have to understand this concept. You don't have to know how to do it to do trig, if you forget. But you have to understand the concept. And the concept is this. No matter what we do to the lengths of the sides, the angles stay the same. Okay? That's the whole point. Is everybody cool? All right. Please turn your pages to page 53. Because... Huh? No. 50 cent. Because it's lame.
50 cents.
And I'm hoping to make people stop saying it by doing that. Because when somebody who you think is lame does something that other people think is cool, you will stop doing that. So I'm hoping to remove some of that lameness by saying it. I hope not.
So you don't like it?
No.
Okay.
I do not like it. I do not like fitty. I don't like bidness. I don't like their words. Say them. W. That's because I hate George W. Bush. And when he was president, because he had a southern accent, he was George W. Bush. And his nickname, because his father was also president, and he was named George Bush, because apparently of all the names in the world, George Bush Sr. couldn't think of another name for his kid. His kid came out and he said, I don't know what to call him. My name's George. I'm going to call him George.
Are they related? George W. Bush and George...
Is George Bush's son.
Wait, no, wait. Like the president of the United States when 9/11 happened.
Yes. His father was the president 8 years before him.
George W.
No, George Bush is the old one. George W. Bush is the young one. I say library because there's a frickin' R in it. I also say Arctic because there's a C in it. And February because there's an R in it. And herbs because there's an H in it. It's not 11 herbs and spices. I'm not a British Cockney guy who drops all his H's. Oh, how's it going, governor? There's an H. Huh? That's countryist?
No, okay.
All right, stop.
George W. Bush,
Stop. Before we go on, everybody needs to see that little black dot by your C. Please move it up one space. I screwed up when I made it.
Okay, then I gotta erase.
Okay, everybody cool? It's the first thing you need to do. Now, everybody, you do not need to use a ruler to do this. I'm going to use colors. You may wish to. I don't care. First thing we are going to do is connect B and F.
That's so easy.
And A and F. Is everyone cool?
Yes.
What angle did I make at the vertex F? I made a 90-degree angle. Is everybody cool? Do I have a triangle yet?
No.
No, of course not. To make the triangle, I need to make the hypotenuse, which is B to A. Agreed? All right. Now, make this ratio. How far is it from B to F? B to F. 3.
3 after 30.
How far is it from A to F? 4. So it is 3 to 4 in that ratio, yes? But there's other ways to write ratios, isn't there?
You can do
As what? A fraction. So what would this fraction be? 3 over 4. And since you're all Canadian students and are scared to death of fractions, you want to make that a decimal, don't you? Which is 0.75. Does everybody agree that all three of those things are exactly the same?
Yeah.
Yes? All right. And you should all be aware that there is an angle, an unknown angle at angle A. Is everybody good? Because we haven't measured it, but we know angle A exists. Yes? Excellent. Now, take your pen, pencil, whatever you are writing with, and connect F to G and G to C. And then B to C. Now, I am going to erase the red. You don't. I am erasing the red for a reason, okay? What have I made now? A new triangle. Does it still have a 90 degree?
Yes.
Excellent. Does it still have angle A?
Yes.
Excellent. Has angle A changed? No. Excellent. So, how long is C to G?
1, 2, 3, 4, 5, 6, 7, 8, 9.
9. How long is A to G?
1, 2, 3, 4, 5, 6, 7, 8, 12.
12. Since you're all students in Canada, you hate fractions, 0.75.
Why can't I just do like the colon, like 3 there?
Because we don't want colons, I need you to see that it's fractions. Is everyone cool?
That's 0.75.
because 9 divided by 2 is, or 12 is 0.75. Is everybody good? All right, now, I'm going to erase the green. You don't. Connect all the way out to H and all the way up to D. Now, do I still have a 90 degree?
Yes.
Do I still have angle A?
Yes.
So what then, without even counting, is the decimal for DH and AH?
75.
0.75. Now, what is it as a fraction? Now count it.
For D to H, 14.
20 is where? That's A to H. Now, you don't even need to count D to H, do you?
Yeah? What?
Well, because if you don't know that, but you know the answer is 0.75, how do you solve this? 20 times 0.75 is, it's not 14, it's 15.
15, but I counted 14.
Is everybody cool? Does, ladies and gentlemen,
I counted 14.
oh yeah, D should have also been moved up a spot. I'm going to have to fix this page. Okay. Regardless, again, teachable moment. The principle is still there. Right? Is everybody cool? Now, what can we say now about these 3 triangles? They are all similar because they aren't the same. They all have different sides. But what does that tell us about the angle?
The angle stays the same.
The angles stay the same. And when I compare the sides, the resulting ratio stays the same.
Yeah.
Regardless of size of triangle. Does everybody understand?
Yeah.
All right, so the general statement is
This is called the what?
the ratio, actually you can just skip it, we'll fill it in right at the bottom. This is called the tangent ratio. Yes, and it holds true for all, please underline all, right angle triangles.
What if it's not a right angle?
Then you can't do this. The tangent ratio, the tangent ratio compares the legs of a triangle. Please notice we did not talk about the hypotenuse, did we?
No.
We did all our comparisons between the legs, right? Now you're intelligent people. What if I put this pink line right here? You know this is 1, 2, 3, 4, 5, 6, 7, 8, correct?
Yeah.
So you know that the pink x over 8 has to equal what?
0.75.
0.75. Right? What if I put this blue line here?
Then that would be
Then what do you know about A to K? A to K is on the bottom of a fraction. K to L is on the top of the fraction. And what will that answer be? 0.75. Because the angle didn't change. Is everybody cool? Regardless of size. I could draw this hypotenuse all the way to Whistler. And I could draw this flat line all the way to the top of Stave Lake. And this angle would not change. Does everybody understand?
Why did you
Which
say
is also how we find out how far away stars and things are. Doing grade 10 trig. Everybody cool?
Why did you say this was hard in the beginning?
Just wait. It's not hard if you pay attention now. Like all math. Everybody cool? Okay, now we are going to get to the biggest problem in the world for math teachers to teach trigonometry. Every single person get out your calculator. And if you're still using your phone, don't be within arm's reach of me because I'll be really angry. Everybody get out your calculator. If you have been lazy and you have not purchased a calculator yet, you cannot do trigonometry without one. So go and get one. Is that clear enough for you?
Yes.
When you purchase one, it must have these 3 buttons on it. Tan, cos, and sin. Yes, yours has plenty. Now,
Sin cost.
everybody stop. So you can do trigonometry. Tan, tangent.
So the calculator on the phone doesn't have it?
The calculator on the phone has it, but I don't want you using your calculator on your phone.
Yeah.
All right, everybody ready? Now, everybody that has a calculator, look at the screen.
Okay.
The screen is right now a big gray box. It might have a 0 on it.
Yes, it does.
Okay? Now, it's got a 0 there. Yes? Now, I have to be, Gerber. You have no idea what I'm about to do. Blows your people's minds. And it makes me want to stab myself in the eye with this next thing. Please look on your screen. Somewhere along the top of your screen, you will see one of the following 3 words. You will see D-E-G, G-R-A-D, or R-A-D. Just wait. Or you will see a little D, a little G, or a little R. Is there anybody in the room that does not, did everybody hear me? Does not, are you looking at your screen? Just look at your calculator screen, Josh. That's all you have to do. Everybody, no, don't say a word. Just look at your calculator screen. Oh my God, don't say a word. Just look at your calculator screen. Then shut up so I can help the people that do what they're supposed to do. Okay? And I can stop wasting my time. Everyone look at your calculator screen. If it does not say D-E-G or D, put up your hand. All right. Tiffany, you have the giant calculator that I have. Please, on your calculator, push the word mode. It is in the top left-hand corner. Please push the word mode. When my calculator turns on, if it turns on, because it's a piece of crap. When you see mode, you will see your whole screen will fill up. Use the Nintendo controller buttons to go down to the word degree, not radians. When radians is highlighted, push enter, and then push enter again, and you'll be in good shape. Diego, look, you've got it. Enoch, you got it. Awesome. Everybody is now looking at D or D-E-G, yes? Your calculator, most of you, it is one button that will change out of this mode. It gets bumped all the time. Whenever you do trig, you must check that your calculator shows deg, or DEG. If it doesn't, you are looking for a button that says DRG, often with an arrow. And you push that button until it says deg or degree. Okay?
What is this? In this button here, it says,
Don't worry about
I
it.
just want to know about. Okay. I know I have it.
Don't borrow problems from the future.
Okay.
Is everybody good? Okay, now, that is only problem 1 of these. Next thing you have to do, every single person looking at a blank screen of your calculator, push the button that says tan. If it writes the word tan on your screen, if you can see the word tan, you have what I call a forward calculator. And that means you do trig the way it's written. So, to do this, if you have a forward calculator, you are going to push the tan button, then you are going to push 3, then you are going to push 5, then you are going to push equals, and you are going to get a giant ugly decimal that starts with 0.700.
Oh, yeah.
Right?
Yeah.
Okay. How many people did not have the word tan come up on their screen? You have a backwards calculator. If it is backwards, then you do the work backwards. Right? You'd think it was complicated, but it's not. So you push 3, 5, tan, but you do not need to push equals. You will get the decimal 0.700. Blah, 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 blah. Is everybody good? All right. Now, every single one of you, tell me the decimals that go here. 0.267 and 1.
Whoa.
Right? Now, stop for a moment.
Can we write these?
Yes. This, if it was a fraction, would be 267 over 1,000, wouldn't it? I'm getting to that. Wouldn't it? Everyone knows that, yes? So if I drew this triangle, and I told you this was 267, what would this be? 1,000.
And then the hypotenuse.
And this angle right here, A, the tan of A is 267 divided by 1,000, 0.267. Agreed? All right. Now, over here, if this is 1, that's 1 over 1, isn't it? Which means these two sides are the same, doesn't it?
So it's 1.
And this is 90. So if these two sides are the same, then these two angles are the same, aren't they?
Yeah.
And there's 180 degrees in a triangle. I've used up 90 of them. So this is 45 and 45. So no matter how big I make the triangle, if you have a 45-degree angle, they're both the same. Does everyone understand? Now, somewhere, I didn't leave myself enough room, but I hope you did. Somewhere, you need to write the word tan finds sides. We're going to talk about what that means in a minute. Write that down, underline it, put a cloud around it, highlight it. I don't care. Tan is what we use to find sides. Is everybody good? And this is how we do it. Because the decimal is the two sides. Test tomorrow on measurement.